Hello, everyone. Welcome to the very first episode of a new podcast called Pone.talk. And I'm your host for today, Adam D. And I'm super happy. Jan, the people have been waiting for you to say it. So can you say the thing?
Hello, hackers.
There we go.
Welcome to Pone.talk.
All right. Thank gosh. So as you already heard, we have Zardus, aka Jan, with us, the infamous. And we also have with us somebody else, the third person. Why don't you introduce yourself?
Hello, everyone. I'm Connor, also known as kanak, or I think I've heard 17 pronunciations of it. I'm not sure what's correct, but that's me.
It's yours. You say what's correct.
It's just a written name. It was never meant to be spoken.
What is a handle if not a name that needs to be spoken?
It's just text on a screen.
Text on a screen. All right. Well, we have two great people with us today and me. So if you're out there listening to us, maybe we're just talking into the void to each other, which is fine because we do that all the time anyways. The idea here
11 listeners on Twitch, man.
Right now? Wow. Or 5 seconds from now or 10 seconds from now, whenever they can hear my beautiful voice in their sweet ears. So the goal here, we want to talk about kind of this podcast. We want to focus on all things Pone College and Pone College adjacent. So to kick this off right from the start, what is Pone College? Which of you wants to take that? The goal here today is going to be talking about the origin. So let's first talk about what Pone College is, and then we'll move to the beginning era. Also, try not to swear since we're live, but, whatever.
Take it away, Jan.
So Pone College is a way of life. Many of us got into cybersecurity, not just to make money, not just to hack things, but to experience the
What sci-fi have you been reading recently?
I've been reading. Hold on, let me try to recover this. I have one word that I'm missing, and it's fucking up the whole thing. Sorry, I shouldn't.
So remember when I said this is a live podcast where I don't edit it later, so people will see that.
Yeah, that's the bad news. Exactly. All right. Anyways, under the foundation of computing lies concepts of cybersecurity, concepts on the edge cases of our understanding of what computing is. And Pone College is a way for people to experience that, to be forced to experience it, and to drill as deep as possible into computers, into security, into what just popped up on the screen.
Apparently I can put chat messages on the screen.
Nice, that's great.
Man, you just cannot stay on track, huh?
I can't. Yeah. It's Pone College is an environment where people can understand what computing truly is. And
through the lens of cybersecurity, right?
And it has to be through the lens of cybersecurity, because on the edge cases of all of this computing goop is where security situations happen. And security situations happen on technology that underpins whatever technology they affect oftentimes. So if you're talking about a computer program, a web application, right? You as a user experience the web application through a browser, through various underlying protocols that magically work until they magically stop working because there's a very specific miscrafted input that trips them up and causes a security issue. And when that security issue occurs, you have to start reasoning about the underlying technology to really understand it. And this goes back throughout history of computing. When you talk about the phone network, like the plain old telephone network, a telephone system.
What is that for people who have grown up only with cell phones?
For people who have grown up with cell phones, we used to have basically these plastic devices that would have a cable going right to the wall. And when you pick up the phone and you hear a dial tone, which is that would be a signal that is an electrical signal going directly from your handset all the way through the landlines into an office of the phone company that was miles and miles away. And these cables connected the entire world in very clever ways where they didn't have to run a million cables from your house to all other houses. And these clever ways worked like magic. So you would pick up your phone and you would dial your number that you wanted to talk to, and then it would connect automatically. But underpinning this, there was a very complex set of protocols and technology that when people started understanding that level and messing with it, the security of the system fell apart. So cybersecurity, like this concept of cybersecurity working on the underpinning kind of firmament of technology goes back close, I mean, let's say 80 years, 70 years, maybe 60 years, but a very, very long time in computing terms. And so Pone College was our expression of this. I got into cybersecurity because what I'm truly passionate about is how this stuff truly works, what computing really is at its very fundamental level. What's interesting to me is, I write this in my dissertation intro, there's a point at which...
Plugging your dissertation in are you... Man.
Building a base for cyber autonomy by something press.
Just to be clear, I don't even think Jan read his dissertation intro. I think
wrote,
he maybe...
It's a write only, yeah.
Exactly. You wrote it once. We did this actually a few years ago, if you recall. We went and read our intros. I think there was like, what was the over-under? Like 3 or 4 typos / grammatical errors, which is not too bad. Like 6 pages.
Yeah, pre-LLM era. Pretty good. Anyways, so, if you start looking at wires and electricity and stuff, I look at this, I don't feel the magic there, the computing magic. And at some point, we start ticking up and up and up, and we get to the point where you're executing instructions, and there clearly is some magic. And I've operated at that level my entire security career because that's where the magic starts. I'm fascinated by this point. And Pone College was an exploration in how do we get people to engage at this level in a way that really speaks to them. That's my ulterior motive for it. Ostensibly speaking, Pone College is a cybersecurity education platform that allows people to dive in.
I was going to let Connor talk about that. You just did your crazy professor level.
Good. Connor?
You were touching on, it sounded like you were going to touch on the basis of like consciousness, like the wires are just the wires until the software is running there, and then that's when magic. So, Connor, why don't you take over? Talk to us about what actually is Pone.college.
Yeah. Okay. So a little bit less philosophy, maybe. So in 2018, this person over here, Jan, came to ASU and had to teach a cybersecurity course. So this is where it really begins. Is he has a task in front of him, which is called teach students, because that's his job description.
And what set us a time frame? What time frame was this?
I think, Jan, you showed up in 2017, right? And then your first real class you had to teach was in the fall of 2018. So like August 2018 is the beginning of
spring 2018 was a real class, my graduate class.
Yeah, sure. Yeah. First real class though in fall of 2018.
Real undergraduate class, we can say.
Yes, real undergrad. Like, there's going to be a lot of students. Instead of like 15 students, there's going to be, in theory, 200. But I'm sure as we'll get into, that number always goes 50% lower. So we had to create this class. And as you've heard from all of Jan's philosophical discussion, there's also a lot of memes that surround all of this. And one of them was, he said, what if we just bought this domain called pwn.college? And so the night before the first lecture, the format of this class in the fall of 2018 was a 3-hour lecture every Wednesday night, which is kind of insane. Imagine listening to what you just heard in the opening of this for 3 hours straight. And that's what those 200 undergrad students enjoyed. So the night before, Ron went and bought Pone.college as a proper memer. And we decided that, I guess as we'll probably get into in this podcast, capture the flag is this very interesting idea of one of the interesting ways in which we can explore these. And we'll get to that later. We had to create this class, and the ultimate idea was, okay, let's have students go through and explore this magic for themselves by hacking real programs in a real environment. In this case, a real environment being like a Linux environment that's just like there and has these security vulnerabilities in there, and students are going to like discover these and hack them, and then they'll do another one and another one and another one. I think the first assignment had students with what was technically an endless assignment. There was no way to actually complete the assignment. For people with any background, I guess, in Linux, it was give us a path to a program. We'll mark it set UID, and you need to use that to read out this flag file. And so that was the very first assignment. And I think Jan had this script that he wrote the night before the first class that somehow like crawled all of the apt software, like anything you could apt install. Somehow he like attempted to install it, and the script ran for like, I don't know, probably 12 hours and installed as much software as possible. So we had like tens and tens of thousands of these programs. And that was just the first assignment. And I guess, yeah, that's kind of the beginning of it all.
Cool. Okay, so great. So you started with, I guess, as all great ideas, it first started out of necessity, right? Necessity is the mother of invention. You needed to teach a class. And then two, you kind of forced yourself to do it by first buying the domain name and then building a thing around it, right? So you kind of force yourself into it. That's fantastic. And so then, okay, so then you took that. So what was the idea? So what was the magic you were trying to get the students to do, Jan, from installing just a bunch of packages? Because the way Connor describes it just seems like, this could be, I don't know, I too can spend 12 hours installing packages on my system, but does that a security challenge make? I should.
Yeah, so initially, and as you said, necessity is the mother of innovation. So it's very important to note that the class was starting the next day. And ideally, we would have had a very well-prepared, brilliant curriculum ready to go, but we did not. We didn't have actually anything. We didn't even have a domain name until very, very late. So that night, in some sense, the initial version of Pone College was a stalling tactic, where we were thinking, okay, well, while we in week 2 we'll get all of the awesome, challenges to start digging into the, underpinnings of computing and understanding cybersecurity and so on. We're going to start with a combination challenge that got people into the competitive mindset, like hey, let's solve these challenges to learn. Because again, all of our backgrounds, both me and Connor, we were coming from the capture the flag community where, and as did you, of course, where you solved these really tough challenges and through them learn how to hack, right? Or learn new concepts. And so we really felt, okay, this is a great way to teach people.
A plug and a mention, Jan and I have another podcast called CTF Radio. If you want to check that out, learn all about all of our, thoughts on Capture the Flag. You can play a fun game and watch those and listen and take a drink of water every time Jan mentions the words Pone College, because it became a meme. And look where we are now. It like subsumed that. But I think the interesting thing that I know you always bring up, and that you always bring up, Jan, like one really good example of a CTF forcing you to learn something is QR codes, right? You have there was an instance where there were a set of challenges all around designing QR codes and breaking QR codes, and attempting those challenges in a capture the flag environment forced you to learn about QR codes on a much deeper level than if you had just read the spec or maybe read the Wikipedia page. So yeah, so then maybe you can take us through. So you came up and I came up, right, learning cybersecurity with capture the flag, but why take that and apply that to education?
Yeah, so I think the QR codes are an excellent example, right? I could have gone to a QR code lecture and the QR code professor could have talked about their QR code, knowledge and said, okay, yeah, and here is the stabilization, the little squares with the dot, and this is what they're here for. And then, this pattern determines a mask that's applied to better randomize the whole thing. And then this is where the data is, and this is where the error correction is, and so on. And I could have memorized all of that, and it probably would have lasted briefly in my mind and then disappeared. But because my exposure to the internals of QR codes was living these codes, like living through a nightmare of QR codes over the course of an entire weekend, where I implemented by hand QR code parsers, extreme QR code, brute force missing bits, and all of this insane stuff. I will never forget QR codes. They will just be burned into my mind for as long as I live.
Oh yeah,
there was
draw a QR code with your hand right now.
I got the yeah, exactly. And so that's what I wanted to achieve with cybersecurity. And that's why we reached for this CTF challenge style of Pone College that now tortures students at ASU and beyond to this day. But the reason that we didn't just go with traditional CTF challenges, because you could also imagine a world where we say, hey, welcome to Introduction to Cybersecurity, go compete in this CTF, compete in that CTF, et cetera. The reason we didn't do that is because historically CTFs are actually a pretty shitty education route for early stage education, because they don't hold your hand necessarily. Even educational CTFs, like aimed at even high schoolers, they're there to challenge rather than to teach. And they teach through challenge, but they have an incredibly high attrition rate. My observation as a CTF team captain looking at new players trying to start up is, about 90% of people that just tackle a CTF will just vanish. They will be defeated by the CTF. And we wanted to smooth that out.
Come join a CTF team, go to a CTF, presumably because they like the concept of security. They're interested in this. They think this may be something that appeals to them. Then they kind of bounce off the hardness. So is that like an intrinsic problem with CTFs, or is it because that CTFs focus on competition and separating people that leads to different, let's say, design goals than the educational aspect that you're thinking about?
Yeah, I think the competition isn't even necessarily the issue. It's the challenge. It's that the CTFs, even at the undergrad, even the high school level, those challenges are created by extremely bright people that are showing off to other extremely bright people. And Connor, you have a good framing for this in the curve.
Yeah, I mean, I think the core problem is, when Young was spending all this time doing this QR code challenge, for example, he said it was like in his nightmares. He probably spent at least 16 hours cumulative over like 2 days staring at QR codes. Is that right? Like something like 16 hours,
30,
maybe even more.
40, yeah.
Yeah.
It was my
Before you
entire
even get
CTF
your
that
first
weekend.
flag, right? Like before you
Well,
know
yeah.
that you're right.
Across four challenges, let's say.
Okay, across 4 challenges. So maybe then, you take this 30 and you call it 7 hours a challenge. There's like, I think a well-regulated person probably isn't willing to stare at something for 7 hours wondering if they'll ever figure it out enough to where you get the flag that says you're correct. And so from an educational perspective, this like what I called a learning wall. I mean, I didn't invent the term learning wall, but it's a bit of a learning wall. And so we wanted to smoothen that out into you get a flag and you get a flag and you get a flag, and it's still all going towards the same kind of final challenge, the same final objective. We sprinkle checkpoints along the way, basically, where you're learning one concept, like Jan maybe figured out how to brute force one bit in the QR code. And then we're like, okay, now you know how to brute force one bit. Let's brute force 8 bits, right? Like start simple, go to the next thing, and you're constantly checking in, which is really good for education because that means you're constantly getting, positive reinforcement that, hey, yeah, you're doing the right thing. You're on the right track. You're making progress versus the traditional CTF mindset of stare into the abyss for the next 30 hours. Good luck. Maybe you'll get a flag. Maybe you won't.
Yeah. And so from that perspective, that first challenge that we launched with Pone College, the very first assignment, it was us trying to figure out like how do we scale this learning wall? How do we get through this issue? And it was an imperfect first step. The second assignment figured out a lot better. So we installed thousands of Linux applications, and then we allowed a user to pick one of those to have super user privileges, and then said, okay, now one per challenge attempt. And then we say, now use that to read out the flag file. And with a program that's meant to read files like cat, that was easy. With a text editor, that was easy. With more complex programs that weren't designed to print out the value of the contents of files, this was a lot harder. And we made certain assumptions. One, that all of our students are familiar with a Linux environment to some extent so that they can do cat /flag. This turned out to be false. We made assumptions that students could self-guide, self-select, like now I'm ready to tackle this harder challenge. Also turned out to be false.
Right, because an interesting, like going back to that design, it's almost like an choose your adventure kind of a challenge, right? Of like, there are all of these binaries installed on the system now because you've installed these packages. You get to decide which one to run as a super user, but how, like, that's almost like a, there's not like a set path that you have told them, hey, first do bin cat and then do it with this program and then this program. It kind of is like the paralysis of choice, right? They like have so much to look at and do. And then adding on top of what you just said of like, but how do I know what programs are installed? How do I find out what binaries even exist on the system?
And the third mistake we made actually was, so actually initially we had a text box, I think exactly what you said, is what's the binary, what's the path you want set UID'd? And then we never actually got around to showing them the path. Did we, Connor? I don't think so. I vaguely have a memory of trying to implement
this. You may have had a scoreboard that showed people what other people had solved.
That's right.
Maybe.
Yeah. And so then we assumed, okay, people look at the scoreboard and, pick the most common solved, which is a common strategy in CTF competitions. But we assumed the level of competition that was not quite evident in practice when we saw it. We also, the fourth mistake we made was we had a grading system where we graded people against each other. And so basically other people
describe that more, because people would say, well, every grading system is against each other, right? Like,
sure.
You can think of a curve, right? There's curve grading where only 5% of the class gets A's and whatever, but you kind of are competing. If everybody in the class got a F, like that's obviously not good, right?
So, yeah. So in a imagine there were 100, not 1,200 programs. A perfect grade would be using all 100 to get the flag. And if you used all 100 to get the flag, you'd get 100%. If you got the flag with 80 programs, you got B-, right? 70 in the American grade system, 70 is a C, etc. But we did something even more insane. We said, okay, yeah, up to 70, it's normal. You get a 70, you have your C. But if you have 85, a score of 85, which is a solid B normally, but everyone else in the class has a 100, you get pushed down to the B or to the C. Like I don't remember the exact algorithm, but basically you had to not only get past that 70%, but then get past everyone else. So it's very possible that 99 programs out of 199% would get you a C on that assignment.
Kind of in your defense, I think makes sense in that you created this challenge. There are thousands of possibilities. You don't actually know where to set the bar. Because I think as the students found out, I think you didn't handle symlinks, right? So like there was all the Python.
We didn't handle /proc properly.
Oh, is that what it was?
There were a lot of symlinks back to /.
Interesting. So yeah, so there's all these different ways, right? Of like that, but essentially at the beginning you didn't know what is a good completion percentage, right? Is it 1,000? Is it 50? Is it 100? Because you had this universe of I don't know. Do you know how many programs there were? Was it
like something like
1,200?
No, it was more than that.
Those are two very different numbers.
12,000?
It was
maybe
over
12,000
programs.
Then 12,000.
Yeah,
I remember the number 1, 2.
Yeah.
At the start,
let's just round it to 10,000 programs, right? But yeah, you have this universe and you didn't solve them all. So you wouldn't know which ones are solvable and which ones aren't solvable. So it actually kind of makes sense in some ways, but then you get these social dynamics in the classroom of now students are essentially competing against each other. You put them in this circumstance, which I heard horror stories of people from law school where they grade on this harsh curve. So there's only like 4 B's available or 4 A's available in the whole class. And I heard that they would go check books out of the libraries on the topic that they were on and then rip out the chapters that was on the test that week so that they could get an edge over other people.
Yeah.
Just completely unhinged behavior.
And part of this was because we we were so behind on the planning. I mean, this was my fault. Connor
This
got
was
pulled
4
into
a.m.
it
the
kind
night
of.
before.
Yeah. And so we didn't have I had no idea, like, I didn't know the level of students. This is my first undergrad class again. I didn't know the level of.
And level, you mean like what their background was, what
That's right.
like educationally, like the level.
Yeah. Because it turned out that even Linux was a surprisingly high bar to expect from the students. And so over the next few assignments, we really evolved the approach. We got rid of this working against each other, being graded on a common curve situation.
And you changed that in real time during the
course, which was a pain in the butt for Connor, who was implementing the grading system, because we say, well, we're going to actually take the higher of your, we'll grade you on 8 different systems and take the higher of them by then. And then we, of course, found the right approach, the gradual ramp up in complexity. And that took us a couple of, I think the very next module was reverse engineering. That was a gradual ramp up in complexity, if I remember correctly.
Memory corruption. And then we decided that people needed to be able to reverse to even.
Yeah.
Because
exactly.
Like, just obv dump it, guys. Like, just go look at it. And then we should teach reversing.
Yeah, and like it was very interesting, a learning process. So we'd launch a thing, we'd see how people are failing. Eventually, one of those weeks, we launched the walkthrough challenges, right? The challenges that would print out, like with memory corruption, this was very good. They'd print out the state of the stack before, the state of the stack after, because, and this, it sounds like I'm picking on ASU students, but this I've seen almost universally, is the ability to debug just doesn't exist. GDB use, this sort of stuff. People really try to avoid that. And so it was a case of kind of meeting the student more where they were. And so gradually all of these modern things about Pone College emerged.
Wait. You say that, but I think many of the listeners may be in the mindset of thinking like, well, you had a website with challenges and the ability to click on a thing to launch a challenge and access it through your browser. So maybe Connor, can you talk about what the actual like infrastructure was like at the time in that first iteration?
Yeah, so as we said, it was 4 a.m. the night before the first assignment was ready to launch. So we had zero infrastructure. I had like some familiarity with like Docker, and I knew that Jan was building this massive corpus of binaries in a Docker image. So the natural thing was like, okay, we need to start students into this Docker container environment. How do we get them into the environment? And so my experience with CTF is generally if you have some remote service, what you're doing is you're netcatting at that service and you're just like typing text to the service. Often like there's a lot of, heap challenges that have these menu driven things. So I was like, all right, we're just going to do a menu driven thing over netcat. And that will be how students interact with everything. So you can imagine you netcat in, and the service just starts up this Linux environment, this Docker container that has all the programs. Before it starts redirecting the input and output of the Docker container, it says, what's your binary? You give it the binary, it makes it SUID, and you're in. From there, we needed an ability to score people. So we added to the menu, an option to submit the flag at the end. In fact, I think you could exit the container, and as soon as you exited the container would die and ask you what is the flag. I think that was the very first version.
Yeah.
So you would type in the flag, and suddenly now we know whether or not you got it correct. I think quickly we added, in order to know who solved what challenge, before you picked the binary, you would say, what is my username? What is my password? And what is my ASU account ID, so that we could track this for grading purposes. And we would literally, how did it work? I think we touched a file on the file system with their username and just wrote the password into it. And then I think a separate file, we just had their username and put the student ID into it. It's just very ad hoc, parsing all of these files on the file system.
The file, in fact, was username : password.
Yes, username : password. Yeah.
Yeah. Early on, Rob who's now part of the kind of core crew, found a vulnerability that allowed him to list all of the files.
Let's pause on that though. I want to wait. Let's wait for Rob's origin story, which will come later once he's back from vacation. But okay, so this is, on one hand, I'm thinking, wow, this is super primitive, let's say, for lack of a better word, right? It's actually very in theme for what you're trying to do. You're trying to teach cybersecurity. So you're using a network connection. It's just a very basic standard in, standard out kind of terminal feel. But the one thing that I actually was thinking is like, actually flag submission sounds, from a user experience perspective, easier than it is now, because you don't have to flip tabs or anything. So we should be thinking about maybe there's something even to learn from these old designs that you did under duress the night before, except for this insane database structure. And
the HT4, it's the best database.
Yeah, I'm going to show this great comment that's coming in from Twitch. So maybe can you talk, without giving anything away with Rob, is there any other stories from that initial iteration of the infrastructure in 2018 where somebody has hacked the infrastructure? And maybe before that, while you're thinking of that, talk about what's the philosophy, because if you think of something like, I'm trying to think of what's the stupid system that they make us use for courses, like the Coursera or
Canvas?
Coursera, Canvas, Canvas. So, if somebody asked a question like, "Hey, has anyone ever hacked your course's Canvas system?" You'd say, "Wow, that's actually really bad. You shouldn't hack into our Canvas because like changing people's grades is bad." So maybe talk about the philosophy and the approach to like exploring the infrastructure. Is that different and separate from the concepts and the cybersecurity stuff that you're talking about in the class? So let's start there and then think about a good story for, has anybody hacked the infrastructure?
So before even talking about hacking from a cybersecurity perspective, we got a really cool situation where gradually this infrastructure evolved. And by year 2, we had a website that you wouldn't have to netcat into. And then there was a terminal, a JavaScript terminal that handled the connection. And someone got frustrated with like frequent disconnects or something and implemented a patch, hacking in the sense of hacked on it a little bit, to make it work, and then sent a patch in mid-class. I think there were a student in the class just kind of got frustrated having to refresh the page to reconnect. And so that was...
They fixed a bug in my infrastructure to like make it less annoying for themselves, basically.
Yeah. And so that was a really cool event that really informed our philosophy, because until then things were closed source, and I think we open sourced it shortly before that event, and then you're like, wow, this is awesome. And have an open source infrastructure. People taking the class can help improve the class. That's incredible. And since then, we've had a really awesome tradition of people sending in, everything from grammar fixes for our challenge descriptions.
So many big grammar fixes.
Yeah, exactly. To big features and everything, which is super cool. So the philosophy there is, one, encourage people to contribute, but two, from a cybersecurity hacking perspective, to kind of, in some sense, practice what we preach in terms of responsible disclosure and analyzing systems. So we have a bug bounty on Pone College. We give out these little badges, bug badges. And there's very few of them out there. I think we've granted 9 or 10, but they each represent someone that has identified a larger scale security issue, everywhere from some of the early ones being able to get root access and then run commands on our infrastructure. I think the person that submitted that challenge, that bounty, didn't realize what they had. We gave them the bug for even what they realized what they had, but what they had was our ability to root the server. This was very early on, before we went global. Since we went global, we've had some pretty major like unintended saws. There was someone that found, again, it was very interesting. They found a really cool bypass that allowed them to solve every challenge. They didn't quite realize what they had. They had something that would solve certain situations unintendedly. And then I fixed it, and then I told them, holy shit. But they got the bug bounty for that. We've had people that go through GitHub's like security filing thing. We've actually granted CVEs for vulnerabilities in Pone College, on the idea that there are other deployments of Pone College that might appreciate having a vulnerability alert. So it has happened. Nothing, brutal and terrible yet. It's been very good faith engagement from the community.
Cool. That's great. Okay, so then let's go back to the origins, because I want to kind of keep us there. So then I think we ended with, there's been like 2 or 3 challenges. You've kind of been tweaking even the content. So what I'm hearing is that not just are you tweaking the approach and the grading style, but also we gave them binaries to exploit, but it turns out they can't actually read the binaries yet. So maybe we should teach them reverse engineering. So then you have reverse engineering. So then what was it like there? So take us from there, which was probably mid-ish semester. Oh, and then also give us maybe some notion. I think the thing that didn't come up is these were 2-week modules, right? Were they overlapping or were they completely distinct?
I think we started out as 1-week modules, if I remember correctly, completely distinct, because we had.
And this is in a 15-week. Yeah, this is in a 15-week semester. So to kind of frame things for people.
Yeah, because we envisioned something that in modern terms, it would have been a combination of CSC 365 and CSC 466, both of which are overstuffed courses as it is. We wanted to have crypto attacks and adversarial machine learning and all of this, all in that course. And so we launched this 1 week of memory corruption and then 1 week of reverse engineering. And I remember driving somewhere, like on a long drive, I don't remember why. And I'm in the passenger seat and these students are failing, and I'm typing out like a treatise on how to reverse, how to debug, and so on. And then, that kind of spawned the concept of the walkthrough challenges, the teaching challenges, etc. And as that early experience informed the later parts of the course, but it also informed later iterations of the earlier material, of course. So over time, we would apply these concepts backwards. For example, this 12,000 pick your own program to exploit first module turned into the program misuse module, which currently is in the white belt material. And it is 51 curated levels that people really enjoy because oh shit, we can read the flag using the find command. That's crazy.
Spoilers.
Yeah, exactly. So we kind of gradually worked these concepts backwards into the material. And even what has recently arisen is, one concept that we came up with as a result of we had this hunch that we want to teach like one concept at a time. And then initially our concept level was reverse engineering, memory errors, et cetera, et cetera. And we've gradually
but broken down, right, into, like Connor mentioned.
Gradually, it became much, much more broken down. And now we have this philosophy of every challenge should introduce one new thing, not, memory corruption. And by the way, there's this thing called a canary. We disabled it here, but, try not to override this variable. Like, it should be just one thing, just the idea that you can overflow a buffer into.
Exactly. Give us an example. So how does that work out in practice?
Yeah. So for example, what the memory corruption module has evolved into is the first level, you just overflow a buffer into a Boolean. So if you just write past the edge of the buffer, boom, you got it, right? Then the next level is you write past the edge of the buffer, but not too far, controlling the length. The next level is you write past the edge of the buffer, but you have to write a specific value after the buffer. So you control an integer after the buffers. And then the next level, I think, goes into starting to control the return address. You have to override the return, so the function returns into a victory condition. And then we start introducing, okay, well, what if there is a variable that you can't override between here and there, or that you have to put the correct value back into it? And then we start exploring this more and more and more. And we've we dug in lower in that sense, like more granular. But then people, I think I think this was the second year that we introduced this. Correct me if I'm wrong, Connor, because people then said, okay, but I have all these individual concepts and I understand them quite well, but I don't understand how they come together, because we intentionally try to avoid that. And then we realized,
so by breaking it down, you made it these disparate pieces that maybe it wasn't clear to somebody who hasn't come up in the other path of how they actually work together.
Exactly. And so then we said, okay, well, hey, let's introduce these putting it all together modules. And now we have basically, like, in our senior level security course, which is where Pone College started, there's a midterm putting it together module and a final putting it together module. In the junior level course, there's only one, but then we try to have these like little challenges that pull in prior concepts sometimes. If you zoom out and just look at Pone College as the platform, one thing that, again, learning from these experiences, we kept running into this problem where the program misuse module is not a good introduction to learning Linux. It is good at practicing from a security, but that initial learning. And so we created a, yeah, exactly. Program interaction, I think, is a good example of where we went too far in this discrete granularity where, we're constantly, it's on our back burner to redo that module or throw it out or something. But we created this Linux module that lets people learn Linux, et cetera, et cetera, et cetera. And then that also has then, because we wanted to keep it as simple as possible, single concept, suffered from people not being able to put their knowledge of Linux together before moving on to the thing. So then, a couple of weeks ago, we launched kind of integrated security challenges. Use your knowledge of Linux to hack Zardus's account, sort of thing. So that we constantly
Does that mean
have
then they have to
evolution.
reply to all of your emails once they get into your account?
That's the dream.
Yeah. Somebody hack me and do my job for me, please.
Yeah, exactly.
Put an LL in there. Okay, so Connor, take us then to the end of that first semester. So how did that end? You kind of briefly mentioned a 50% attrition rate. Was that actually like roughly how many students did you start with? How many did you end with? And what was the as you kids say, the vibe like in the class towards the end?
Jan, do you remember, did you have your terrifying lecture the first year you ran it, or was that not
No.
the second? Okay. So the first year, I think actually we maybe didn't have a 50% attrition rate. We probably had like 30%, 40%, but probably not 50% of people
probably a 20%
like,
regret rate.
Yeah, like I think people realized they were spending like 30 hours a week in our class, and this like professor would just ramble for 3 hours every Wednesday night, and it was just like chaos. But mostly it was good vibes, I think. I think the people that stuck around, we were just kind of having fun learning together. Like one of the things Jan mentioned earlier of that first module was this abuse of like the proc file system, where instead of specifying bin cat as a challenge to solve, you could specify like proc self root bin cat. And that was based on how our infrastructure was designed. That's a different program. And so like Jan would show off, the proc file system and GDB, and we're just kind of messing around in class. It was pretty good vibes, I think. Once we started the second iteration of the course, though, we realized that probably not everyone wanted to be there, which is totally fair. Not everyone is signing up for a 3-credit class and expecting that this is about to be a full-time job. So I think by the second
it is an elective course. I think
it is an elective. It was not required to complete.
We can get into that later. But
yeah, I think anyone that really wanted to learn this stuff like hardcore and like this is their passion, they probably loved it. Anyone that was there of like, all right, I'm down to do some learning, but not something that's 40 hours a week of learning, didn't want to be there. So we learned by the second iteration.
Yeah, then you gave the warning lecture at the beginning. So this is a really good point that you brought up that I want to hear more about, especially thinking about the differences between how Pone College started and where it is today. You mentioned like crazy 3-hour ranting lectures. So how was like the educational material delivered to the students, and how does that differ versus the approach now?
Yeah, so in 2 words, it was depth first. So all learning happened depth first.
Oh wait, before you go, maybe we can maybe this comment can let us. Oh, I guess we should read it for the audio version. One of my favorite things about Pone College lectures is that students can feel comfortable to have fun with the professors during the content instead of just scary professors reading bullets off a slide.
Yeah. So we don't do a whole lot of slides as a part of our style of learning. Most of the learning happens in the challenges. And this is why, over time, we've developed this idea of like gradual concept by concept. You learn in the challenges. And so nowadays we have evolved a little bit to have some lectures discussing the topics and, trying to be quick and to the point a bit more. But certainly in the beginning, it was what I think can only be described as depth first, where as soon as someone had a thought or an idea, suddenly the entire lecture would go there, and then just straight down into insanity. It was
3
really the
hours of
first
it.
semester. Exactly, 3 hours. I think Jan was nice enough to give everyone a 10-minute break in the middle on most days. Actually, it wasn't even 3 hours. I think it was 4 hours. And we would run an hour late. Like
We would
students
run late
would,
because it was,
yeah.
we were the last class in the room. And so we would
Yeah,
just stay.
so Jan would just keep going past the end of the class, sometimes up to an hour past. Just kept going.
So you kind of, I guess, sounds like, hey, maybe that was not an effective learning method or teaching technique in some sense.
It was for some people, but probably not for the average person.
So then when did the lectures, like, so if people go to Pone College now, you go to one of the dojos and modules, you'll see not just challenges there, but also slides and lectures. So are these like recorded lectures, just a scary professor reading bullets off a slide?
There's definitely a slide involved. It's still very chaotic, I would say. Jan, do you want to talk about this thing called COVID?
Yeah. So basically, Pone College had a kind of a radical evolution during COVID. We were lucky in that the ASU course is taught in the fall. And so we had some head start on thinking about online teaching rather than getting thrust into it. But during COVID, the default, you have a Zoom room full of squares, blank squares that listen to you ramble, and then every once in a while someone unmutes and asks a question or something. And
it's like every meeting I have with you.
Exactly. And then and we still had to do that, which that was interesting. ASU's official, online synchronous education delivery was through Zoom with the squares and everything. But shortly before the semester started, we kind of realized two things. One is we don't want to do like a Zoom thing. And I think this was Connor's thing, where like, what if we take this opportunity to actually make a community around this style of education?
Yeah.
And this was the days of all of the kids that grew up gaming on Discord growing up and entering college. And so, Connor, I think you suggested Discord, right?
Prior to this, we were just on Google Groups as like
Google
our
Groups,
communication channel.
That's all you need. I still remain steadfast. To do a class, you just need one website that is static, that updates with assignments, and you need a Google group to talk.
Right. It's perfect. People would email and then someone, anyways. So, but no, we suddenly had a Discord. And then I went from saying it's unlikely you'll pass this course without signing up for this Google group to saying it's unlikely you'll pass this course without joining our Discord server. And then we kind of dual streamed because we still wanted a more engaging delivery vector.
I think realistically, it was just for the memes. Like, I thought it would be so fun if just class was on Twitch. Like, this was the height of Twitch memes. Like, people were like pog champing in chat and stuff. Like, this, I was like, why not just run your class like this? This is just amazing. Way better than the Zoom stuff.
So, we retro justified it with a bunch of educational philosophy of engagement and all of this stuff. And I wouldn't say we got like massive pushback about Twitch academically, but, we got kind of questions like, really, Twitch? Why not Zoom? And I could say, hey, Twitch is incredible because it is a platform designed for a presenter to engage with an audience, and that's what teaching is as well, right? So,
I think the downside there is you miss the interactivity that you can get teaching on Zoom. I did find during the pandemic that the chat in a Zoom class was actually great when students were engaged because they could ask questions while you're lecturing, and you can like just like we're doing right now with the chat, like it is shaping our discussions because we're seeing what they post. That is great. But I think you lose out on the discussion aspect because like typing, I think, especially with the delay, is not the same thing as like, hey, unmute and like tell us your thoughts on whatever this topic is, right? And then other people can respond.
Early on, we had that's right. So one of the original first lectures, every cybersecurity course starts with Connor's favorite topic of cybersecurity ethics, right? And so in the in-person days, we would have a discussion about Phineas Fisher's attack on hacking team and what the ethical implications are, and et cetera, et cetera. And we tried this in 2020, and it didn't really work. Right? We're just like, well, what does everyone think? And then some people would type something. And we were even dual homing to Twitch and Zoom. So I had a Zoom in an AirPod, and when people would unmute, I could hear them. I'd repeat the question, and it'd work. I don't know. It didn't really work super well. And so we just, by the second time doing this still online and COVID, we abandoned Zoom.
I think it makes sense, right? Because as I've definitely seen the reach of Pone College and the stuff that's being taught is like, I think part of that reach is because of Twitch, and using Twitch like does get, and like this is a great comment. Like if the ambition is teaching at scale, it sounds like it would scale better with a Twitch chat than with a Zoom call, which is 100% true. It's just it's very interesting kind of to see those dynamics. Okay, we're getting close to the end, so bring me home. So that first Pone College. So when did you say, maybe netcat interface is not the best? Let's end there. Like that'll be the last thoughts, and then we'll save other stuff for the next week.
So I think just interjecting one thing is,
no.
Once we had,
you do what I say. I can mute you.
You're right. Interface.
You didn't think I could, but I did. Anyways, go ahead. I did mute
you. Once we moved everything online in that regard for 2020, which we had to do, we realized, well, wait, we have our ultra scalable platform. We have everything is online. Everything. Let's just open it up to the world. And I think I made a Twitter thread at the time and just said, this is what we're doing. This is what we're planning to do. Join us. And we had a huge cohort of non-ASU students following along with the class. That full-time job Connor mentioned, they did it without grades as resulting from it. They just did it. It was awesome.
Connor, do you remember? Not only that, but some of those top global performers just became TAs for the class. So it's not only that they were taking advantage of it, they were making it better for everyone at ASU as well.
Yeah. So they would stick around on the Discord, helping people, answering questions on Twitch. It was just an incredible phenomenon.
Community,
which I something that mirrors
ancient alien guy.
Exactly. It mirrors what I used to see in my Taekwondo studio as a kid. Like the more experienced students would help the it's an incredible thing to see. It's a true Pone martial art. But when did we go beyond the text box with the terminal in it? Do you remember, Connor? It was after 2021. I want to say it was.
So first we had netcat, and then we went to web. Right, that was a big transition.
Yeah,
so
xterm.js.
That happened because I think at some point I learned about CTFD, and I was like, wait, we could just the web exists. We could use that instead of netcat. I just had this epiphany. And so I just rewrote the infra to be on the web instead using CTFD, because then I didn't even have to figure out how to make it so someone could log in.
And VS Code.
Well, that was much later, I think. Initially it was just, you could hit start, and I think we quickly got SSH out. So you could SSH in. So no longer did you have to netcat and have the very crazy things that happen when you're interacting with the terminal over netcat instead of SSH. You had SSH. That was the first big, wow, this is getting kind of fancy. And then when we opened it up in a beta form, where we did that, I think at HitCon 2019, we did a public beta of Pone College where we announced it. On the plane to Asia, I just sat there and learned about xterm.js, and I was like, wow, we could just use WebSockets in the browser and have a terminal in the browser. And so I think I spent the entire international flight there for to come up with a cool demo or something on stage, just writing the Xterm.js implementation so you could access in the browser.
Yeah, and that was 2019.
And then it was like 2-3 years later that we got VS Code, I think, or 2 years later. Yeah, because initially we were going to do Jupyter notebooks in the browser, and then we're like, wait, but we could do VS Code.
Yeah.
And then we got the desktop a year later after that.
Yes.
Yeah, so now you can multimodal, let's say, Pone College. You can SSH in, you can use VS Code, you can use the terminal, or not the terminal, the desktop in the browser. Yeah. So all kinds of stuff, but we can get into more of like why that's important later. So yeah, we will end it there. We're at an hour. That's where we want to do this. The goal is to do this once a week. We'll stream it live. We should be live on your favorite podcast platforms soon-ish once we figure all this stuff out. You can check out our website at talk.pwn.college. So this is Adam D on behalf of Zardus and the guy who can't even pronounce his own handle, Kanak. So thank you all for joining us, and hopefully we'll see you next week. And I don't know, do you have a good tagline at the end, Jan?
Goodbye, hackers.
No, lame. That's like the most obvious one.
I used that to sign off from the 2020 semester, and like, I don't know, people were tearing up, at least saying that they were tearing up. It was pretty good.
I do not believe that. I don't believe that for a second.
Wow. Memes were saying, oh man, we should talk about the whole evolution of the meme extra credit and stuff.
One of these. Like yes, there's a lot of good content ideas. You can ping us on Discord. We're happy to, maybe somebody can create like a podcast channel or a Pone.talk channel or something. I don't know. Happy to do that. Happy to get ideas. All right. Keep learning. Let's go with that.
We're going to work on that.